Okay, we're at the 24-hour mark, and I'd like to show you something, and I'm going to explain something because this is for the patent for fusion, and this is directly to the United States Patent Office when the patent advisor looks up this video, lady or gentleman. Okay, so we're at the 24-hour mark of running the fusion reaction. The power supply is a regulated power supply based on ohms going into my proprietary copyrighted circuits that run the fusion reaction. Okay, now that power supply is straight DC. There is no AC in that power supply. This is what I'm going to explain to you, and this is how you're going to understand this. Okay, that electrode is cherry red hot. Okay, there's no question about that, but I can touch this electrode and it's cold up here. Give you a little idea of how hot that electrode is. You see that? It's cherry red hot, ladies and gentlemen. Okay? So right now it's purple, and now you're starting to see the registered color of proton deuterium fusion in the boron cycle out of ocean water in situ. Okay, this is my amp meter and voltmeter. The amps are set at 7.5, so the lambda swing is right around 3 volts. Okay? Alright, 3 amps, I'm sorry. Not 6, 3 amps. Here's my voltage. You see that? I'm on the 2 volt scale. I'm going to go to the millivolt scale. A little bit off the millivolt scale. Okay? I'm going to go to the 20 volt scale. As you can see the 20 down there. Okay. I'm going to go to the 200 volt scale. You can see the 200. Okay, there's no funny business here. Now, first I'm going to show you this. I'm going to move over here to frequency. Now, you notice the frequency is 3.5 kilohertz in lockstep with the amps. In lockstep with the millivolts. Okay? That's technically 4 times over Faraday and double Tesla. Now remember, Michael Faraday, DC electricity, threw the potential so far. Nikola Tesla threw the potential twice as far, giving the understanding of the word over unity. You cannot have over unity in the same energy potential, but you can have AC is over unity of DC, and that's how Nikola Tesla won the patent of history. You guys got it. Okay. This is 4 times over Faraday and double Tesla. But now I'm going to show you something that's even more amazing. Okay. We're using no volts here. Okay? None at all from the power supply. Now let me get it to DC. I mean AC. Now, you see the AC volts? Okay? The power supply is a DC regular power supply that you're going to be able to test and put your meters on when we come to this patent validation. But the AC is coming back from the circuit in the electrical, optical, electrical Magneto effect of superconductivity. So what I'm creating here is a Meissner field. The energy is going into the electrode from the environment. It's not coming from electrons in the wire. Now, let me go back to frequency for a minute, and let me explain something to you. 1 volt, this is proof. I've said this several times in several videos, but I'm making it very clean for you at the patent office so you don't have to search all these videos. 1 volt equals 1 hertz. Now, you know that in AC because 60 hertz, 60 volts, 120 doubled, okay? To get 120 volts. Now, we've got 3.5 thousand hertz. Doesn't that look more like to run a plasma reaction? 3,500 volts to run plasma? That's right. That's not coming. You're seeing this is the true input volts right here. That's it. That's all you're going to see. Now, I've ran these videos for 24 hours now, so you can see where we started, when everything settles down, heats up, so forth and so on. Okay? Now, let's just see from this reaction. Here's our bubbles. Okay? We're still bubbling. We got a little higher potential of pressure in here. NASA calls this process pressure retention vessel. It's how they do it. They do it with liquid instead of regulators, and on the specific gravity liquid. That's why you're not seeing the mass amount of bubbles that you saw in the other videos. But let me just show you something. Let me just break that pressure chain here, and we'll see if we're still producing a tremendous amount of stream. And now we're going to run this so you can see that there's no way that this steam built up pressure in this dewar and the reaction chamber. Okay, we're still producing that's enough to turn a steam turbine, and that steam is deuterated with hydrogen deuteride, and it's definitely explosive steam. There's no question about it. Okay, so we've done 5 gallons of water in 24 hours. 5 gallons of water in 24 hours with this much energy input. Okay, now you can see that we've removed the pressure. You can see the boiling. Here's the set point of the heater. It's been like that all night long. I said it last night in the last video, and I haven't touched it. I think I even dropped it down. It's just there so we can prove that we're not putting any excess heat in the reaction. Okay? So let's this video, you guys have all seen bubbles and steam and all that stuff in the other videos, and that was enough for you. Let's look at the understanding here. Now we're talking about the electrical understanding. So this video is going to be titled The Electrical Understanding of Superconductivity. In fusion is 4 things: superconductive, amplifying gravity, biological, and linear magnetism. Okay? LC current. You cannot run a fusion reaction in a tokamak reactor that's bound by a magnetic field because it needs the environmental energy to come in. There's an infrared signature coming off there, but the infrared signature is mostly being produced in. So when you put a digital thermometer on that, it's going to say 180 degrees. That's it. But you know from that temperature that electrode's closer to 2,000 degrees, or 900 degrees Celsius, or 900 nanometers infrared signal. Okay? So there's your update. Here's our water refill reservoir. comes down here and just keeps the level nice and calm so that the reaction can run all day and all night. And unfortunately, I'm headed to the ocean to go get some more water. But in closing, these are 2 batches of Formula U. Okay? And we've talked about Formula U before, but Formula U is, in this process, an OMRI-listed organic process to produce Formula U. And when we're done, this is pharmaceutical grade right here when it's filtered, but when we're done moving this equipment into the shop that's being built right now for us, we'll be in a food safe environment, medical grade. Okay, but let me show you something else. This is our precipitant, and this is Formula U from the cold reaction. What you're seeing up there is pharmaceutical grade from the hot reaction. This is topical, but this is our precipitant from the cell. But let me show you, this is just in the oxidated state. Okay, so let me just show you something. That is what we get. That is why proton spin technology exists as an element company. Okay, unfortunately, we're in a orange bucket here, blowing away labs. Here's another bit of it. You see that? That has a industrial value under elements that will also be included later in chemical processes for elements for the industrial market, kept copyright, trade secret. Here's the product. Okay. And I'll say that once again for the memory of Pons and Fleshman. They said that it was not fusion that was going to necessarily save the world. It's the products out of fusion, or the list of elements that we've been able to produce with different frequencies increases our periodic chart by fold. We already have 4 metals that are not on periodic chart produced out of the fusion reaction. So that's just a little bit of horn blowing. Let's see, let's just close this. Give it a second. There we go. I was playing with the electrode. Okay. There's your update. We'll go back over this one more time really quick. Let me turn on the light so you can see. Volts. Okay. Let me close the last part of the electrical understanding. You've got 5 volts AC, but the circuit, the input is DC. That is a tremendous amount of voltage being produced in the total circuit of this fusion reaction. Okay, And I said total circuit because there's a proprietary understanding that I'm not necessarily interested in divulging here on YouTube. We'll keep that for the patent papers. But it's dealt with in Max Planck, in the Max Planck calculations, okay, of phonon resonance. So, I just thought you'd like to see that. We're definitely producing more energy out than in. Okay, and I like to calorimeter in glass. I don't like to calorimeter in anything else because I want to be up against the environment. I don't want the electrical magneto effect to mess with something that's stainless steel bouncing against the walls and heating up the walls. I want glass. And that electrode's 44,000 BTUs, okay, with my input of 1.6 watts and my output 44,000 BTUs. That water is 180 degrees right now, okay? We're boiling water at 180 degrees, making steam at 180 degrees, not 220, okay? That's a big difference in the reaction, okay? I'm not sure if I forgot anything, but there'll be other videos if I did, but I think that pretty much covers the electrical understanding of superconductivity and fusion. Thank you, ladies and gentlemen, and have a good day.